Have you ever wondered how holograms work? You know, those impressive three-dimensional images that seem to float in midair? Well, buckle up, because today we're going to unravel the magic behind the science of holography. First up, we need a coherent light source, and that's where our trusty laser comes in. Coherent light is just a fancy way of saying that the light waves are all in sync, like an impeccably coordinated dance troupe. Next, we introduce a beam splitter into the mix. This clever device takes the laser beam and splits it into two separate beams, like a magician effortlessly cutting a deck of cards. One of these beams is the reference beam, and the other is the object beam. Now, let's place an object in the path of the object beam. Think of this as our star actor taking center stage. The object beam bounces off the object, carrying information about its shape and surface back with it, like a dedicated detective collecting clues. Here's where the magic really happens. The object beam and the reference beam meet again at a photosensitive recording medium, a bit like a high-tech rendezvous. They intersect and create an interference pattern. This is the secret sauce that gives us the 3D effect. This photosensitive medium records the interference pattern as a complex pattern of light and dark regions. It's kind of like an incredibly detailed map of a hidden treasure, capturing both the intensity and the phase of the combined light waves. To view the hologram, we shine a laser or white light source onto the developed holographic plate. This light, acting like a seasoned explorer, passes through the recorded interference pattern and undergoes diffraction, recreating the original object beam's phase and intensity. As this diffracted light exits the hologram, it reconstructs the original 3D scene, like a skilled artist recreating a masterpiece. What we get is a virtual image that appears to float in space. You can move around the hologram and view it from different angles, just like you would with a real object. Consider it like this. Imagine a friend drew a picture of an apple. You'd see it, but it would be flat, right? Now, imagine if they could draw that apple in such a way that you could see all sides of it at once. That's what a hologram does. It's this unique ability to reproduce both intensity and phase information that makes holograms so impressive. They're not just for sci-fi movies, though. Holography has a wide range of applications, from making credit cards more secure to creating stunning art, and even helping scientists visualize complex data. So, next time you marvel at a hologram, remember the intricacy of the process behind it. It's not magic, but it's definitely science at its most magical.